All right, good afternoon and good morning wherever you are. Welcome to another one of ABYC's Thursday webinar series. I'm Dave Broadbent, ABYC's Education Director, and we have our lead instructor, Mike Bonicker, who's actually going to be taking you through our presentation today on propane systems. If any of you have taken any of our online classes, you've seen his face plenty of times. And I don't know if someone's going to ask it, but he doesn't have the count, I don't think, of how many reels are behind him. So you could try asking the question. He may not answer it, though. So thanks again. Welcome back. It's good to be back. It's been a month since we did our last one, and we're excited to pick this up again in the fall. So let's get through some basics here before I turn it over. Some updates. Our Supplement 60 will be launched at the end of this month. July 31st is when it is our publication date for the new standards. So we got some great ones in there, including the Tech Info report on lithium-ion batteries. So definitely look out for that. If you ordered a book, we're shipping the first week of August or so, and we have some good stuff. So always take a look at those standards. The weekly webinars were monthly for this month, today, and then in August. So I'll show you the date for that coming up. But keep that in mind. Once August rolls around, or September rolls around, we'll pick it up a little more. As always, we send the registration out to members first to make sure you guys can get seats there. And any topics you could think of, please let me know. We're continuing to build this out for the fall and for the foreseeable future. It's been a really great thing for us, and we really enjoy providing it to you guys. CEUs, same process as always here. So there will be a link that you will get in the follow-up email if you're watching this live. If you're watching it on YouTube afterwards, a link will pop up at the end of the video. Click on that. It'll take you over to our website, and you can apply for those CEUs. If you have any questions on that, you can email education@abycinc.org. And any questions you have during this presentation will be held to the end for Mike, and I'll read them off to him. So you have that little box there for questions, just type it in there. Online resources, we have our fundamentals textbook as always, and I wanted to talk a little about our workbook again. I know I've hit on it a few times, but we actually have the copy in hand now, which is pretty great. So if it's something you're interested in, I know we've seen a lot of interest from boaters or from businesses to train their employees, and there's nothing wrong with that. We will sell you the instructor version too if you want the answers and whatnot. I would tell you though, it is based on the textbook, so it does work standalone, but you can really get a little bit more out of it if you do have the textbook. So if your business thinking about using it for that, I'd consider getting that textbook also. Self-study certifications, if you're taking an online class with us, you use ProctorU, and that's all through our new learning management system where we would continue to load free micro course classes and some full classes. So keep your eyes peeled for those. Our interactive online classes, we've had a lot of fun with these. They've been great success for us. Actually, we have a little bit of higher passing rate. The schedules usually work out Tuesday to Thursday for an hour and a half each day. Time dependent, we have some ones that are coming up that may apply to some people overseas a little better off. And we do have some unique ones going on right now that are a little shorter, but that's generally the path for them. If you go to abycinc.org/schedule, you can see all that information there, and we have everything built out through the end of 2020. We're going to start looking into 2021 and what that looks like, but as of now, we got everything through December 2020, so feel free to register for those. The next class, or the next webinar will be on August 20th, still finalizing the topic there, but by then I will also have the full fall schedule. So we're not going to go necessarily every week in the fall, but 2 to 3 times a month, maybe one month we'll do them all, but we'll have the whole schedule pre-published. So you guys can mark your calendars, see what you want to see, and take it from there. So we're pretty excited about that. And with that, I'm going to go ahead and turn it over to Mike and drop off screen, and we can talk about some propane. So here you go, Mike.
Great, Dave. Thanks very much. Thanks everybody for being here today. It's my second one of these. I've been teaching a lot online. Some of you out there have been in the classes. Those are going very well. So don't hesitate if you have interest in some of the certification online classes that are available and will still be available through the end of the year and most certainly into next year. They've been working out very well. So today we are going to get myself out of here. We're going to be talking about propane systems. It's one of those high risk systems that are on the boat and certainly need to be done properly in order to in order to keep the boat safe, keep everybody else safe. And it's not, the standards are not difficult to understand. It's not a lot in the weeds. Some very basic components and the way things are done will ensure that you can either install or replace components in the system very safely without having any issues. So I'm going to drop my picture off here so you guys can see the presentation correctly, and we will get started. All right, so we're looking at a fairly typical installation on what appears to be a pre-made section of a locker intended specifically for the purposes of being a propane locker. And we'll talk specifically about what makes that so, what we need to do in order to have a dedicated locker for our propane system. But in order to have a proper setup, and we'll run through these quickly, and then we're going to look at each of them specifically as to their intentions. Number one, we have to have a very well sealed, tightly latched locker that has an overboard drain, and that's a drain. It's a vapor drain, not meant to be a liquid drain, although it will drain liquid if for some reason liquid was to get into that locker. But that is there to drain off any possibly leaked liquid or propane gas that would come out of the system inside the locker. And that drain has to be at the lowest point, of course. Got to have a pressure regulator, which is this component right here. You have to have a pressure gauge. Pressure gauge is required by ABYC in a liquid propane gas system. You have to have a shutoff valve. We'll look in some cases, the valve on the tank suffices. Otherwise, you will need a remotely operated solenoid shutoff valve in the system. The one big stipulation is that all supply lines between the source, between your locker, between the tanks, and whatever components are running off of propane, all of those lines have to originate inside the locker. We do not want lines taken out of the locker and teed off of to feed multiple components. If you need to do that, all of those tees need to be made inside the locker. We want to eliminate the possibility of as many leaks as possible and eliminate all connections as possible outside that locker. It's also required to have a comprehensive instruction book, information supplied with the system, supplied with any components that are installed. That is a standards requirement that information's got to be supplied to the owner or to the boat operator. They need to state, and we'll look at this specific test later. Those instructions have to state that a test is to be made every time the cylinder supply valve is open for use and after any events that may affect that system. We all know that very few people are going to do this, but they have to be provided with that information and understand that that is supposed to be done. Again, we are in a very high liability oriented world, and you're dealing with a very the possibility of a high liability system. So everybody has to make sure that they cover their butt as far as what should be done. Not that the end user is necessarily going to adhere to that every time. So we talked about the fact that every system has to be fitted with a pressure gauge, and this is a fairly common setup with the gauge connected to the regulator itself. That gauge is there to read the cylinder pressure side of the pressure regulator, the high pressure side. The reason it's there is to provide a very easy way to perform a simple test to make sure that the system does not have any leaks, and we'll talk about the specifics of that test a little bit later too. All the components of the LPG system have to be rated to at least 250 PSI. That's hoses, valves, regulators, gauges, whatever it might be. Everything in that system has to be rated to at least 250 PSI. Every system installed has to be provided with a plainly visible sign that contains this basic information. Again, these are warnings for the most safe operation of this, possibly dangerous system if it is not treated properly. So a system is designed for LPG. We are not trying to transfer liquid gas from one place to another. We also are not, we can't connect this system to CNG, compressed natural gas, which is a different beast altogether. Compressed natural gas was fairly popular some years ago. It had the one benefit of being lighter than air, so it would dissipate into the atmosphere, whereas LPG, liquid propane gas, is heavier than air. So the system cannot be switched between the two. Compressed natural gas is a completely different entity and has very different requirements. You don't see it too much anymore. It is fairly well fallen out of favor. It has to be stored in very large, heavy tanks. It was not very efficient. Didn't last very long. So it's liquid propane really has taken over as the main player in this genre, this scenario of using gas as a power source. A requirement to keep the cylinder or valves closed when the boat's unattended. When the appliances are not being used, they want you to close the cylinder valves immediately in any emergency. Keep the empty cylinders tightly closed. Close all appliance valves before opening the cylinder valve. Apply ignition source to burner before opening appliance device. You might say that could be a little bit difficult sometimes depending on the scenario, but it's there because we want that flame to ignite, to ignite the first gas that comes out of wherever it's coming from the burner. We do not want any buildup of gas to accumulate before a source of ignition is applied. And the requirement to test the system for leakage in accordance with the instructions required to be posted in the vicinity of that cylinder each time the supply valve is opened. On gasoline-powered boats, that sign also has to contain this information, that gasoline vapors are explosive and any open flame appliances can ignite those gasoline vapors, causing death or injury. What that means basically is you don't want anybody operating the stove while you're refueling the boat if you have a gasoline powered boat. All the system components have to be able to operate in ambient temperature range between 0 and 140 degrees Fahrenheit. And again, if you're using properly rated, usually marine rated appliances, components, they should all fairly standardly meet that and all of these requirements. Only systems using LPG cylinders of the vapor withdrawal type are permitted. Cylinders that can admit liquefied gas into any part of the system are prohibited. Again, we're not trying to transport or transfer liquid petroleum gas from one point to another. The only thing we want to admit into that system is the gas at lower pressure. There's a couple of Rube Goldberg setups for you there. Components in that system need to be secured properly. We don't want them to move around, mainly because that could put strain on the distribution system, our fuel lines, the propane fuel lines. So needless to say, neither of these scenarios is even remotely proper. Ignition protected equipment. Any of you who have been in the electrical classes, any of those, understand when we're dealing with gasoline and in this case propane. Anything electrical in the vicinity of those systems has got to be rated to be ignition protected. In this case, for liquid propane, it's required in any compartment containing our liquid propane appliances, cylinders, fittings, valves, or regulators. Now, in most cases, that is just going to be the locker, inside the locker. All electrical equipment capable of being a source of ignition needs to be ignition protected and so marked. If it does not say ignition protected on it, do not assume it is ignition protected. There can be no open flame devices around around electrical equipment that's not ignition protected. And our propane system components, no open flame devices. Can be no exhaust pipes or heat producing devices capable of producing a temperature in excess of 300 degrees Fahrenheit near the components of our LPG system. Electrical devices in the following compartments do not have to be ignition protected. Anything that's in the accommodation space or compartments meeting the definition of open to the atmosphere. That is defined by ABYC as a space having at least 15 square inches of open area per cubic foot of compartment volume exposed to the atmosphere outside the vessel. That is a very specific definition per ABYC that constitutes a compartment that meets that open to the atmosphere declaration. But stoves, anything that's in an accommodation space, a stove, a heater, whatever else it might be that's running off of the device that's running off of propane, if it's in an accommodation space, it in and of itself is not required to be ignition protected. All the cylinders that are used have to be DOT compliant. You should have a DOT number on them, no matter what they're made out of. Every appliance must be fed from a regulated supply line that originates inside the cylinder locker or protective enclosure. So as we discussed, and we'll mention this several times, every connection in the system, except one, which we will see in a minute, is required to be inside this locker. We do not want any joints and connections made outside of that propane locker. There's a requirement to have a readily accessible, either manual or electrically operated shutoff valve installed in the low or high pressure line at the fuel supply. So it's required to have a manual shutoff on the cylinder. And if you have remote appliances, you have to have a solenoid valve, an electrically operated valve in the fuel line. Now it can be before or after the regulator. The regulator is there to reduce the pressure coming out of the tank. The only thing you have to watch is to make sure you get the properly rated solenoid valve. I have seen installations where somebody puts a low pressure solenoid valve in between the tank and the regulator. It is not going to shut the gas off when you turn the breaker off, turn the switch off. So it is allowed to be on either side of the regulator. Just make sure it is rated either for the high pressure side or the low pressure side. The valve or its control must be in the vicinity of the appliance that's being fed in the event of a fire. Fairly typical panel there. If the cylinder shutoff valve is readily accessible from the vicinity of the appliance, the shutoff valve on the supply line is not required. So if the only thing you're feeding with propane is a barbecue on the aft deck or wherever it might be outside, as long as that shutoff valve, that tank is, within a step, readily accessible from the vicinity of that appliance, you don't have to have an electrical shutoff like a solenoid. The valve or its control needs to be operable without reaching over the top of any flame. Open flamed appliances, mainly cooking appliance burners. What do you think about the location? This is our shutoff for the solenoid. This is our fire extinguisher. How about now? Not a good place for either one of those. So there's actually a standard requirement that That shutoff has got to be operable without reaching over those burners. In addition to the valve required at the cylinder, if you have a multiple cylinder system, it has to be provided with a shutoff valve or automatic check valve at the cylinder manifold so that each cylinder can be isolated from the other cylinders. Fairly typical. You can buy this assembly as is for a 2-cylinder system. Our pressure regulators, every system has got to have a pressure regulator. The pressure coming out of that propane tank is way too high to be used without a regulator, just like you have on your grill at home. It's got a pressure regulator on it. That's what that little round silver thing is, to reduce the pressure coming out of the cylinder. These regulators have to be specifically designed for use with liquid propane. And they have to be rated to deliver gas under whatever varying appliance loads there are at a pressure not in excess of 14 inches of water column. That is a specific measurement of pressure, is water column. So 14 inches of water column is the maximum pressure that the gas can be delivered after the regulator. It's a picture of a fairly typical regulator, although you don't see too many that actually have this little hose barb connected, and we'll discuss what that's what this is the relief device. The pressure regulator is required to have a low side pressure relief device integral with the regulator. And we'll see another one of these where it's a little bit different, but this is the pressure relief on the low side, the regulated side of the regulator. The requirement for that pressure relief is that it will discharge between 2 and 3 times the delivery pressure of the regulator. And again, if you're buying properly marine rated components, they should automatically meet these requirements. All relief valve outlets shall discharge into the dedicated locker or to the open atmosphere outside the boat. Like I said, you don't normally see these that they have an actual hose barb on them where you could vent this out specifically on by itself. Normally, it will vent into the locker and then go out the vapor drain that is there to drain off any leaked vapor inside of that locker. This is a pretty good diagram here of a system with one minor mistake. This requirement here for a minimum 1/2-inch ID overboard discharge hose, that is not correct in the fact that the requirement is that the minimum ID of any component in that overboard discharge is 1/2 inch. That means the pipe to hose fittings, the ID of the pipe to hose fittings cannot be any less than 1/2 inch, which means more than likely you're going to be using at least 5/8, if not 3/4 inch hose as that drain hose. This is the minimum is on the absolute minimum restricted diameter of any component in that drain. So if you've got an ID of a 1/2 inch, you're more than likely going to have an OD of 5/8 or 3/4 on that fitting, meaning you'll need 5/8 or 3/4 inch hose to suffice. We're still on the topic of the relief valve. So the relief valve, this is a specific standard for the relief valve that its discharge point has to be at least 20 inches away from any opening to the cabin or the hull interior. Again, most of the time that's going to fall into the fact that it's going to discharge inside that locker. So this is not just going to be our locker drain, but it's also going to qualify as the relief valve point of discharge is going to be our locker drain in most cases. So that locker drain need to be far enough above the water line that it's not submerged underway. Should be located away from the cabin openings and engine exhaust, any opening into the interior by 20 inches. Now, if you had a pressure regulator that had that little go back a second, it has this piece. If you wanted to run a piece of hose from this relief relief valve discharge through a gland, an airtight gland, through the locker and to a vent fitting on the side of the boat. You're more than welcome to do that too. Seems like a lot of effort to go through. One more hole in the locker that you've got to seal up when allowing it to vent into the locker is perfectly fine. But you can see here, we've got two devices. This is where our T needs to be made. We've got a regulator, we've got our shutoff solenoid. After the shutoff solenoid, we've got our T to provide basically a home run. All of our runs to our appliances have to be home runs from inside the locker. There's a little more typical pressure regulator. You can see that little screen there. Again, this is the section that is the relief valve on the low pressure side of that regulator. The regulator is going to reduce the tank pressure to less than 0.5 psi. Again, that's goes along with that 14 inches of water column pressure regulation. It's another way to look at it. Another spec is less than 0.5 psi should be the pressure coming out of that regulator. Marine regulators have a 300 psi gauge on the high pressure tank side. We already talked about the necessity, the requirement to have that gauge that is rated to 300 psi. If these things are normally made of aluminum, depending on the conditions that they're used in, and we'll see where they can be outside, not necessarily in a locker. You come across one that's extremely corroded, don't try to clean it up, just replace it. That is proper procedure, is just to replace these things. They're not overly expensive, and it's just not worth the time to try to clean them up. All right, the lockers themselves. The requirement is that all of our cylinders are required to be installed in a dedicated locker, or they can be installed on the exterior of the boat where any escaping gases will flow directly overboard. Now, this certainly fits that bill. This seems to fit that bill pretty well. This kind of fits that bill. You've got a scenario where this locker is going to have a drain, it's going to have an opening on the bottom, and you could possibly have an accumulation of liquid propane gas in the well of the cockpit. If the through halt, if your scupper drains go down below the water line, there's no way for the gas to drain that way. And on a very still day, you could possibly have an accumulation of propane gas down in that locker well. This is, questionable again as well. It's protected, which again is another requirement. You can't have these things out in the weather, even if they are not in a built-in dedicated locker. If they're on the exterior of the boat, they still have to be. The requirement is that they are protected from the weather. Now, this flybridge covering has, drains here, which you can't see from this picture, then it's probably okay. Any escaping gas is going to make its way out. It's going to stay down along the floor and make its way out through any drains that are in that. But you would certainly need to have some sort of opening at this floor level overboard from this contained area where that tank would be. Cylinders, valves, regulating equipment, and safety devices are required to be readily accessible, secured for conditions, protected from the weather. That is a requirement. Even though you can have propane tanks outside the vessel, mounted outside the vessel, they are not supposed to be out in the weather. Need to be protected from mechanical damage. Lockers must be designed to minimize the likelihood of use as a gear storage locker. Now, this is sort of a different scenario where a gear storage locker is being used as a propane locker. This is not good by any stretch of the imagination in either direction. That's why you'll see in a lot of these propane lockers, they're designed to not have much space in them. Even ones that are a little bit larger, and we've seen a few of these pictures where especially there's two cylinders, they will mold the locker to basically just accept those 2 cylinders and the regulating equipment. That's because we don't want other people storing other stuff in there. That is a dedicated locker solely for the purpose of storing our propane system components. The storage requirements for either unconnected reserve cylinders or empty cylinders is exactly the same as cylinders in use. They've got to be inside that dedicated locker. See a lot of small boats that have rail-mounted propane that takes the little screw-on green canisters, and the green canisters in a drawer or in a compartment down below. They do not belong there. If you have any propane on board, it is not to be stored in the cabin, and it's not to be stored in any place where, if it were to leak, gas could make its way into the bilge or into an occupied space. There's one there. You can see, perfectly molded. There's very little space to put anything else in here. That is not by accident. That is by design so that it does not get used as a storage locker as well. The lockers themselves are required to be vapor tight to the hull interior, located above the waterline. That's a very difficult requirement to fulfill when you're retrofitting an aftermarket locker, a locker that goes inside of another locker, and we'll see a picture of that here in just a second. They got to be constructed of or lined with corrosion-resistant materials. They are to open only from the top with a securely latching, gasketed, covered top. They must be capable of being quickly and conveniently opened without tools. The requirement is for a built-in locker that it opens directly to the outside atmosphere. We don't want anything precluding access. We want this thing to be completely open to the atmosphere when the access, whatever that access is, whenever the lid is open. There is one of the aftermarket type lockers. If one of these lockers is installed inside a boat locker, inside a lazarette, wherever it might be, the locker is required to be located as high and as close as possible to that boat locker's opening. We don't want this thing stuffed down under this corner over here. It's got to be right out in the open so that when you open the lid to that locker, it is open to the atmosphere, as it would be if this was a built-in scenario. And a lot of older sailboats, a lot of that did not come with a built-in propane locker. People want to install them, want to install these standalone lockers, and they're very nice. They meet the requirements, the ones that I've dealt with. But in a lot of scenarios, it's difficult to get this in a locker and still have fall from the bottom of the locker to an overboard drain fitting downhill, being above the waterline. That's a very, very difficult thing to, it's one of the most difficult parameters to meet when installing one of these lockers on an older vessel. Most older vessels, the cockpit's fairly low, the coaming's fairly low, the lazarette lockers, the seat lockers are fairly low to the waterline, and there's just not a lot of space to get that locker in underneath the lazarette locker lid and still have space between the bottom of this locker and somewhere overboard to put a hose downhill from this point to our overboard without being below the waterline, which it has to be above the waterline. When access to the equipment is the locker's open, the cylinder valves must be capable of being conveniently and quickly operated. System pressure gauge dials need to be fully visible right there. You open that locker, you need to be able to see that gauge. As we discussed, liquid propane gas is heavier than air, where CNG is lighter than air. Therefore, we've got to have a vent, a locker drain vent in the bottommost portion of that locker. Yeah, that's not there for water. If this thing is gasketed correctly, you're not going to get water in that compartment. It is there to drain off any liquid propane gas that might leak out of the system inside that locker. And again, the minimum diameter of any component in that drain vent can be no less than ½ an inch inside diameter. It's not the hose size, the minimum diameter of any component in that vent system, which would be the fittings. 3/4 inch hose most of the time. There's our same picture again. Our vents, again, same stipulation, need to be let outboard without pockets through the hull to a point lower than the locker bottom, above the water line with the boat in a static floating position. At least 20 inches from any hull opening to the boat interior. Now, even this one here, above the water line with the boat in a static floating position, I installed one of these one time, and it absolutely met that criteria. But it was in an older sailboat, and anybody deals with sailboats on a regular basis knows, especially when you motor, the boat squats. So where the water line was here, when the boat was sitting still, the locker was above the water line perfectly fine. With this being right at the transom, when the boat was running, the water line was up here, which means water filled that well to about that level. So it wasn't the best scenario in the world. It did drain out again, mostly fully, but that's going to cause a lot of corrosion issues inside with the tank itself, with all of our connections, electrical, plumbing connections. It's just not a good scenario. So in most cases, that locker needs to be above the water line, even when the boat is running in motion. Our fuel lines, pretty simple. You've got to be compatible with liquid propane, capable of withstanding the stresses and exposure of the marine environment. They can be either UL21 liquid propane gas hose, which we're looking at on this side, or corrosion-resistant metallic tubing, such as annealed copper tubing, standard grade K or L, which is very typical, especially in older boats, to find propane system plumbed with copper tubing. The lines, flexible lines have to be equipped with permanently attached end fittings, either suede sleeve or sleeve and threaded insert. There is no hose clamps. There are no hose clamps at connections in liquid propane gas systems. No hose clamps, period. Nowhere. Doesn't work. If you're using annealed copper tubing, the tubing needs to be connected by means of flare fittings. The requirement to use long nut flare fittings is there. The short nut flare fittings like this have been known to cause fatigue failure due to vibration, so they want more support at that connection, at this flare connection. So if you're using copper, you've got to use long nut flare fittings. Our fuel lines need to be protected from physical damage, covered, running hose, running conduit. They need to be accessible for inspection. Mainly, you're going to look at physical damage around areas going through bulkheads, which we'll see in a second, things of that nature. The one other area, and this is the only extra connection allowed outside the locker, is that if you do run your main plumbing in copper, you have to have, of course, a flexible section of hose when connecting to a gimbaled stove to allow the stove to gimbal properly. So that is the one extra connection, or the one connection that ABYC allows outside of that locker, is a short section of flexible hose at a gimbaled stove. Got to support our fuel lines to prevent vibration damage, chafing, with corrosion-resistant clips or straps, or they can be run in a conduit or in a tray. Again, when we pass through the wall of the locker, through any bulkheads, our lines need to be protected by close-fitting grommet, sleeves, or sealant of non-abrasive material wherever they pass through those things. And of course, they've got to be vapor tight going through the wall of the locker itself. We never want to use our copper LPG fuel supply lines as an electrical ground. Seems pretty obvious, but sometimes you got to state the obvious. So once we have our new component or new system installed, testing is a big deal. Again, high liability situation. If something is not right, if it is not tested properly, and an accident occurs, there's going to be big trouble. So anytime you deal with a propane system, make sure don't take any shortcuts in checking, testing the entire system, checking all connections and things of that nature. So per ABYC, after installation of an entire system or new component, but prior to connection to the regulator or the appliance, we need to test that system with an air pressure of not less than 5 psi. Cylinder valve, after that, the cylinder valve should be checked for leakage at its connection to the cylinder by application of a leak detection fluid. After we perform those tests, the complete system can be connected subject to the following pressure test. With the appliance off, the stove, the heater, whatever it might be turned off, we want to open the cylinder valve to pressurize the system, put pressure in the system. Then close the cylinder supply valve. You want to observe the gauge reading. That's why the gauge is there, and we don't want to see any drop in pressure in less than 3 minutes. Now, personally, I would want to see it for a whole lot longer than 3 minutes. But that is the specifics by the standards, is that the pressure should remain constant for not less than 3 minutes. Again, if you find any leakage, drop in pressure, you've got to leak check the entire system again. With detection fluid, detergent is fine. The only thing you have to watch out using detergents is that they sometimes contain ammonia. You never want to use any detergent, any solution for leak checking on copper that contains ammonia. It will and can attack brass fittings in a very short order. Those fittings can develop cracks and fail, whereas initially when you made your test, there was no leak there. So just if you use a leak detector, most cases it is not going to have ammonia in it. So you really don't have to worry about that if you are dealing with using some sort of a detergent solution to do your leak testing on these systems. And finally, never use a flame to check for leaks. Again, one of those things that just needs to be said. Great picture, eh? All right, that's it. Thank you very much. Questions?
All right, thanks, Mike. We got a few questions here. So in reference to the 1 pound tanks, if you don't have a storage locker, where would you store those tanks?
If you are going to have propane on board, you've got to have a dedicated locker to store the tank. In that case, you may be looking at putting in one of those small standalone lockers if it can be installed properly. But the only other place to put it would be if you had a small locker on deck, where again, if it can't be out, it's got to be enclosed to some extent, but whereby if there was a leak, it would have a small vent opening that it would leave that locker and drain overboard essentially.
Right. If you have a propane locker on the flybridge, do you have to have a drain hose run down to the water line so that the fumes do not flow overboard and into the cabin below?
That would be extremely, yes, extremely, extremely suggested, correct.
All right. CNG is becoming harder to obtain. Please discuss conversion from CNG to propane. What needs to be changed? Issue of CNG locker shape different from propane.
Yeah, honestly, because I dealt with CNG a little bit 20 plus years ago, and not to the extent of dealing with ABYC requirements per it. Dave, I don't know if you know off the top of your head, to my knowledge, I don't know specifics in the difference, and I can't even recall off the top of my head if there is a specific CNG standard. But
we do have one, but yeah, it is less and less used.
Yeah, and it's even becoming, even propane, even as popular as it is, one of the most difficult things with propane systems is having a reliable place to get propane tanks refilled. You know, everybody these days basically exchanges their gas propane tanks, and I know that became a problem for the boatyards and marinas that I worked for, where we didn't have our own way to fill propane. We did at one time, but because of safety regulations, we didn't do it anymore, and it was very difficult a lot of times for our customers to find a place on the water, especially to get the special propane cylinders that are used in most boats filled. But with CNG, that's something you'd have to spend a little bit of time researching into. I will not profess to be an expert on CNG systems.
And if you're looking for the standard, it's A22 is our CNG standard. So you can take a look at that, and maybe that'll help a little bit.
Thanks, Dave.
All right. Is a locker on deck that drains onto a flush deck, no well or cockpit, and subsequently through a scupper satisfactory? In this case, adding a vent through the deck seems like introducing a hazard.
From that basic description, I would think that would be okay. Again, if it's on deck and it has a way for the vapors to escape that enclosure, and those vapors can make their way overboard, then you're living by the intent of the rule of the standard.
All right. Do you know who makes the pulpit-mounted propane locker?
I believe Todd. I think Todd makes the same company that makes tanks. I haven't installed one of those in a very long time. They're very easy to find, very, very common. Not difficult. You look them up online, you'll be able to find them in 2 seconds.
All right. The cover of the LPG locker must be necessarily horizontal and at the top, gasket type, or it can be vertical, cover totally sealed and above the whole system. I think it's just a comment there for that. Whole system cylinder, pressure gauge, and regulator. So
I'm not sure what a vertical cover would be.
Yeah. Feel free to clarify that one a little bit, Eduardo, if you'd like. Next question, how does ABYC feel about French Euro boats that will have splices in the low pressure line outside of the locker? This comes up a lot in surveys.
Yeah, no, again, not supposed to be any splices, except for that allowable piece of flexible hose connected to copper tubing for gimbal stoves. We do not want to see any splices connections outside of that locker.
All right. Any comments about horizontal tank installation?
No, I have seen them. There isn't any requirement for the tanks themselves to be in a specific orientation. You know, as long as the tanks are designed. I don't know if it will require a specific tank to be able to operate in that orientation. I almost think that it would have to, because I would think there's a possibility of a normal propane tank in a horizontal configuration that wouldn't necessarily be able to utilize. I don't know whether it would utilize all of the material inside the tank properly, or if it would possibly emit some liquid propane into the system.
Right. If a system is changed from CNG to LPG, do the lines need to be replaced, or can the same lines be used with a new regulator, locker, etc.?
In most cases, I would think it's going to come down to the pressure. I don't know for sure, but I think CNG operates at a higher pressure. Don't quote me on that, but that would be my gut instinct.
Yeah, and I would take a look at that A22, and I
Yeah.
think most likely there's something in there that says designed for the pressure of the system along those lines. So, kind of support what Mike said. So take a look at A22, and that might happen.
My experience with CNG with those, they're like big scuba tanks. And just because of that, I believe that CNG is at a higher pressure.
All right. Should there be a separate solenoid for a heater as opposed to one for the stove?
There doesn't need to be a separate solenoid, but there has to be a way to shut the solenoid off near each device.
Right. Is CSST, corrugated stainless tubing, permitted in boat installations?
Corrugated stainless tubing. I'm not specifically familiar with what that is, but by the standard, as far as distribution lines, you are allowed copper or you are allowed properly rated flex hose.
All right. What about monitoring equipment? Is there any required?
No, it's not a bad idea, but there is no requirement for a leak detection system.
All right. I saw a flapper on a propane drain. Is that correct?
Probably not. It's going to be highly unlikely. You're talking about that drain, because that locker is sealed. That drain is allowing for both heavier than air propane gas to leak out, and also allow some replacement air to come in that same tube above it. I would think a flapper on that drain would certainly not allow that to function properly.
And along the same lines, can the locker vent hose have a check valve?
No check valve.
Well, we already addressed this one. Does the locker requirement apply to the small butane cans?
Yep.
All right. Getting through here. Are there standards for tank size and construction?
No standard specifically for tank size and construction, other than the fact that they have to meet DOT. They've got to be meet DOT requirements.
All right, and just to confirm, I don't need a solenoid shutoff valve if my cylinder is next to the appliance and allows me to quickly close the cylinder valve itself in case of a problem with the appliance.
That is correct.
All right. Does ABYC make propane notices for lockers?
I don't believe so. That is normally a manufacturer's issue. I'm not sure where you would come up with them if. That's a good question, actually. I've never considered that. Most of the time, they are there with existing installations, factory installations. I'm not aware of specifically being able to get a hold of one for, say, an aftermarket installation.
We got a good comment here. For horizontal tank installations, a tank must be made for that purpose to sit on its side, and I think that's actually in the standard.
Yeah.
Let's see, what do we got? I got time for one or two more here. Let's see, LP tanks must be installed with a valve at the top. Inside tank, there must be headroom for the liquid propane to turn to gas. So I guess that applies if it's sideways or not there.
The horizontal tanks, yeah.
Yeah. Got a couple comments on CNG cylinders are up to 5,000 PSI. LPGs are 150 PSI depending. So that just supports what you were saying.
That was my gut feeling.
Mm-hmm. Do the propane tanks need to be replaced with age?
Only dependent on physical appearance, basically. Most of the tanks that people use are aluminum. If it's inside a locker that's sealed properly, you don't normally have too much of an issue. They will last. It's going to corrode on the edges first for the most part. If you get a considerable amount of corrosion there, you might want to start thinking about replacing them. It's not likely that it's going to start leaking in the area of the tank containment itself. The bottom edge is probably the most likely place that it may corrode first. The stainless tanks, people still try to use those and do. They just don't hold up terribly well, and certainly going to be replaced more often than the aluminum ones, more than likely.
All right, I think that's going to about do it for us, Mike.
All right.
I'll jump back on screen with you real quick. And once again, thanks everybody. We love doing these, and we're excited to put out our fall series. So keep a lookout for the calendar on that one. If you're looking for CEUs, as always, if you watch these videos, Matt's going to place it link somewhere around. I try to point, and he usually puts it somewhere funny. So click that link. You can apply for CEUs. August 20th will be our next webinar, and then we'll have it set up through the fall. And any questions, a follow-up email tomorrow, we'll have that link for those watching it live, and Mike's email address will be there. So feel free to ask any questions you have on this stuff. Mike's our lead instructor. This is what he does. So really enjoy doing these. Thanks, everybody, and we will see you next month.
Thanks, everybody. Thanks, Dave.